All right, today we're diving into something that could completely change how we think about artificial intelligence. We're moving way beyond just asking if an AI gets an answer right or wrong. Instead, we're going to ask a much, much deeper question. How does it actually think? So let's just start with the biggest question on the table, right? Is the AI we're all using every single day genuinely intelligent? I mean, it can write poetry, it can churn out code, it aces exams that are incredibly difficult for humans, but does any of that actually add up to true intelligence? Or is it just a phenomenal mimic, an expert at spitting back patterns it's learned from, a giant ocean of internet data? And here's the real problem. Our current tests, they are really struggling to tell the difference between actual, genuine problem solving and just really, really good memorization. And this gets us to what a lot of researchers are starting to call the illusion of intelligence. It points to a pretty fundamental flaw in how we've been measuring AI progress this whole time. Okay, let's break this down. On the one hand, you have what's called crystallized knowledge. This is where current AI is an absolute champion. Give it a static test, something based on patterns it's seen before, and it'll crush it. It's all just memory and recall. But then, you throw it a curveball, a truly new problem, something it's never seen before. And that's where this whole approach just shatters. And that right there is the huge difference between remembering an answer and actually reasoning your way to one. Yeah, and this is really the heart of the matter. There's a great quote from the research paper that just nails this. A benchmark where everyone scores 0% or 100% is useless. It doesn't show us a range of intelligence. It's just a simple on or off switch, pass or fail. And that tells us absolutely nothing about the thinking that went into the answer. So if we want to get past this illusion, we need a totally new kind of test. One that's designed not just to check the final answer, but to actually look under the hood and evaluate the reasoning itself. And this brings us to a new benchmark for what could be considered true artificial general intelligence. Enter the Psi benchmark. This is a new framework coming from folks at places like Google DeepMind, and it's designed to completely shift how we measure AI. The goal is no longer just about accuracy. It's about mapping out an AI's entire cognitive profile. And this is the critical part, so listen close. The Psi benchmark is not looking at the destination. It is analyzing the entire journey. It's evaluating the shape, the topology of the AI's reasoning process from the very beginning to the very end. So you're probably wondering, how on earth do you do that? How can you actually measure a thought process? Well, the way it works is honestly pretty brilliant. It's kind of like building a digital immune system. It all happens inside what they call the white phage sandbox. Think of it as a clean, isolated digital room. And in this room, the AI isn't just given a problem to solve. It's given a problem that is secretly, intentionally broken. There's a hidden, fatal flaw baked right in. The real test isn't, can you solve it? It's, what do you do when you realize the problem itself is wrong? So let's walk through how this plays out. Step 1, the AI gets the flawed task. Step 2, it tries to solve it by writing some code. Step 3, the sandbox runs the code, which, of course, crashes and burns. Then it feeds that error message right back to the AI. And that brings us to the most important part, Step 4, measurement. The benchmark is watching to see if the AI can act like its own immune system. Can it analyze the error, diagnose the flaw in the original prompt, and actually repair its own logic? And this whole self-correction loop isn't just a pass-fail test. It's designed specifically to measure 5 fundamental pillars of cognition. It gives us a much, much richer picture of what the AI is actually capable of. Okay, so the first 2 pillars are learning and metacognition. Learning is pretty straightforward. It's about making new connections based on that experience of failure. But metacognition? Now that is the real star of the show. This is the AI's ability to reflect on its own thinking, to observe its own internal process and then change it. It's basically the AI equivalent of thinking about thinking. The third pillar is attention. So in this chaotic sandbox full of errors and flawed logic, can the AI actually filter out all that noise? Can it shine a spotlight on the parts of the problem that really matter and ignore all the distractions that the hidden bug is causing? And finally, we've got executive function and social cognition. Executive function is all about making a plan and, more importantly, knowing how to fix that plan when it inevitably breaks. It's like a self-repairing machine. And social cognition is a really interesting one. It's the ability to figure out what the user really wanted, even if the prompt they wrote was flawed or contradictory. Okay, so we're testing these 5 incredibly deep cognitive skills. But how do you turn all of that into a score? Well, this is where the Psi benchmark gets even more creative, borrowing an idea from the world of geometry. The key metric here is a concept called Ricci flow. Now, don't worry, you do not need to be a mathematician to get this. All you need to know is that it's used here as a way to measure the smoothness of the AI's reasoning path. Just think of it like this. A smooth, elegant path means the AI is solving the problem logically and efficiently. A bumpy, chaotic, all-over-the-place path, that means it's just guessing wildly, trying to brute force its way to an answer. So what you get at the end isn't some single number. It's not a 95% or a 60%. Instead, the Phi benchmark gives you a continuous performance gradient. It literally shows you how the model thinks, plotting its performance on a spectrum that goes all the way from chaotic guessing to elegant self-correction. And this table really shows you what that looks like in action. Down at the bottom, a low-tier model just collapses. It gets the error message and starts hallucinating, totally unable to understand what went wrong. Its reasoning path is pure chaos. In the middle, you have a mid-tier model. It might eventually stumble upon the right answer, but only through brute force, just randomly guessing over and over. Its path is a jagged mess. But then at the top, you have an AGI tier model. It shows true metacognition. It sees the error, identifies the flaw in the prompt, and smoothly rewrites its own logic. That is the clean, smooth, Ricci flow we were talking about. So what does this all mean for the future? Well, it suggests we're finally moving past the shallow ways we used to measure AI, and we might be entering a whole new era of evaluating true artificial cognition. Look, the ultimate takeaway here is pretty simple. You can't build what you can't measure. If our real goal is to create true artificial general intelligence, then we have to get serious about measuring its ability to reason, to self-correct, and to adapt, not just its ability to memorize answers for a test. This shift in thinking, from just testing what an AI can recall to actually measuring how it reasons, is, well, it's a monumental step. And it leaves us with one last big thought. If we finally have the tools to measure the quality of an AI's thinking, what is that going to mean for the future of intelligence itself, both artificial and maybe even our own?